So, all right, I guess I'll just go ahead and start. So really quickly, before I really get into this, everything I'm talking about I have online on GitHub, and I posted the link in the description for today's meetup. So if you're ever curious, if you want to go back, it's right there. Cool. The chances of me changing things to break them after today are pretty slim, but hey, it could always happen. So you probably already saw me pulling up Arduino IDE over here. So just to give you a really quick description of what exactly is going on. So if I pull up the serial monitor right here, give that a second. So attached over here, I do have this Arduino, and there are some wires in the way, so I'm having some trouble picking this up. So it's an Arduino Pro, 3.3 volts specifically, and that little red thing on top, that's a wireless transceiver, RFM69 transceiver. So that is connecting with, as you can tell right there, Raspberry Pi. That's over here, and same concept, it has the same transceiver, so they're sending messages back and forth. Just to show you, I can go ahead and type a message here, you know, whatever text, hit enter, and then it'll say it sent it or not. And then I can also plug in the Raspberry Pi, and you'll see it over here, not there unfortunately, but we'll give that a second. Whenever it decides to come back, no, maybe?
Wiggle the mouse.
Oh yeah,
Yeah, sometimes the Pi shuts off the HDMI.
Yeah.
I don't think so.
Hey, there we go. All right. So let's see. Let me try sending a message one more time from the Arduino, and we should see something down there. No. So something is wrong with the connection on that. Well, now's not a good time to debug it. So just trust me that it's supposed to work. At least it does the other times that I was running this. I was worried the cables would get knocked around, so oh well, that happened. So we're not going to talk about actually wiring them up. That's something I'm assuming you have pretty much already done. So as far as the Arduino code for this goes, I mostly copy pasted from this website right here. So this is a SparkFun tutorial. Basically, it just kind of went through and told you exactly, you know, what you need to buy, all the wiring, etc., and even gave you the code. So I changed like 2 lines for some things, and that's about it. So those links are in there. But now that I have the really quick general description out there, let's go ahead and start talking about this stuff. Really quickly, here's my bio. I'm not really big on giving a bio. The main stuff that I just want to mention is my background is in software development, but if you notice the choice of programming languages there, it's very different from something like C or C++, right? Especially the embedded side of things, right? I'm used to, you know, having a debugger for something and all that kind of stuff. So everything I'm talking about is something that I worked on for a project that I started while back, and I wanted to just kind of add a bunch of things to it. So those kinds of things, as far as the goal is to create an embedded app that communicates over basically a custom Wi-Fi connection, essentially. Sorry, not Wi-Fi, radio frequency. So not Wi-Fi, not Bluetooth, etc. And because I'm a software developer and the things I'm used to doing are, you know, creating an easy build and easy deployment onto the board itself, and I also really like unit tests, so I like doing that with any kind of project I make. So those were the real goals of what I wanted to do for my project. And all the code, everything I'm showing you is mostly a copy paste from the thing that I was working on. I just changed a few names and kind of pulled out a few extra classes and things like that. We already kind of talked about the hardware specifically. The Arduino Pro, I'm specifically using a 3.3 volts just because the transceiver itself works off of that, and I didn't want to have something in between to do whatever conversion for that, because I'm told that could be bad if I put a 5 volt to this thing. I don't actually know. This isn't something I have background in. And I mentioned the Raspberry Pi. The Raspberry Pi is just here to be the secondary device for all this stuff. It's, aside from telling you about it right now, I'm not going to talk about it anymore. So a few things about this transceiver, just so that way you kind of get a little background if you haven't worked with one before. Again, it's not Wi-Fi or Bluetooth, it's, you know, radio frequency, it's the stuff that stuff uses. The range is limited by an antenna. So I was told on the internet that it can go like maybe even a mile with a really good antenna. I mean, it's the internet, so I'll trust it. Over here, yeah, following that tutorial online, it just said, hey, stick a wire in there and you're good. So the range is like a few inches, I think, at this point. So the transceiver itself has a network, or you choose a network of 0 to 255. I arbitrarily chose the number 100, so we're only talking on network 100. Every network has some number of nodes, 0 to technically 255. However, that very last node is the broadcast mode, so everything will get it, and that's it. So you do, when you're setting this up, you have to specify the network and the node and all that stuff for setting up. With this transceiver, apparently it also has a built-in acknowledgement mode, so once it gets a message, it'll just automatically send something back. And it also can perform message encryption, so you give it a 16-character or 16-byte message, essentially the password, and then it will do encryption on that. So that's about it. So when we're talking about creating an embedded application itself, everything is pretty much similar to what you would expect of any other kind of software you're making, right? Type out some code, hit compile. At the end, we'll get whatever compiled application, and then we just need to put it on our deployment target. In this case, it's an actual board. So just copy paste those files over. So talking about the different things, when I was starting and learning this and starting with my zero knowledge in this space, I started with the Arduino IDE, like right when I mentioned that website where I copy pasted everything. That's where I started with. So there's a lot of good stuff to using the Arduino IDE. The pros are it's very easy to set up. It has a lot of abstractions for things. It is C and C++ under the hood, even though it's kind of, like I said, you really abstracted from it. And especially this last one, adding an external library is really easy because I just copy-pasted or downloaded a zip file of the library I needed to work with that transceiver, and I was good. The downside is, and especially this first one right here, that it's built for prototyping. It's really good for prototyping, but as soon as you want to kind of expand beyond that, it gets a little bit harder, right? Multiple files for a project and keeping track of that, and especially if you ever work with a team of people, things get a little bit harder at that point. And the project system, I said proprietary, it kind of is, it's specific to the Arduino, but part of it is also that the documentation around it, I think, just doesn't really exist, so it's, yeah, all right, seeing other people nod and say no. So one day, I heard about this other thing, ATMEL Studio, that sounded great. There's a lot of tools that are essentially built in. You can work with C or C++, or even Arduino. Actually, it kind of has its own thing. If you're like me and you're very familiar with working in Visual Studio, you'll notice that it looks very much like it. That's because it uses the same shell of Visual Studio, but it has its own tools kind of plugged in for all that stuff. Some of the cons are actually there's a good bit of manual setup for things like just setting up a lot of specific flags that you want to use, that kind of stuff. It's still a little bit more than something a beginner would want to jump into immediately. But it's a little bit more, at least in the route that I want it to go. And the other thing there about the proprietary project system. So then, when I was on my quest to try to figure out how I wanted to do all this stuff, I kind of came across the concept of CMAKE. And so if you haven't heard of CMAKE, who has not heard of CMAKE? 2 people. Okay, cool. So, well, pros and cons list one more time. So, CMAKE is essentially, basically just you're using a script to make everything that you want to do. So, instead of having a full IDE, you can have a full IDE that uses CMAKE, which is what I'm going to be showing today, or you can just kind of have everything, separate script files, however you kind of want to go with that. So it is cross-platform, it's cross-IDE, and we'll kind of talk about that a little bit. And then you can add unit tests, yay, with a bunch of exclamation marks. The cons are the amount of time to set up. I didn't really know much about what I was doing there, so I lost a lot of time with that. And it's very easy to lose some of those cross-platform benefits, meaning that if you want to develop everything on a Windows machine like I was doing, and maybe you're with another teammate who's on Linux, then you got to worry about things like path issues and some of those things. So you can be good. It's just a little bit more upfront work that you have to do with that. So what's installed on my machine now, in order to get all of this to work, I do have Arduino on there. This is actually needed for this thing that we're doing. I do have ATMEL Studio, and then Visual Studio is what I'm going to be using to actually show doing all this code. The reason we need the other two, Arduino and ATMEL Studio, is because those have some extra tools, essentially, that you are going to be hooking into to be able to use. The other two items are NMake and CMAKE. So NMake is actually installed by Visual Studio. If you want to go that route, if you just include the C++ tools, it gets installed too. CMAKE is its own separate thing. So if you remember one of those first slides, I was talking about my experience with software development and languages. You really didn't see anything on the C or C++ side of things. So part of that is, I'm used to a certain set of tools, that kind of thing. But also, when you go a little step lower, you start getting into the embedded sort of things. So when you're at that point, you're missing a lot more things. For example, you don't have the standard lib, so you can't use things like the new keyword, because that's part of the whatever standard library it is. Maybe it's not standard lib. I'm not exactly sure where that lives, but it's somewhere, right? Other things, there is some trickery to create unit tests, and you can't debug easily. I still don't know how to debug. So there's that. So with that out of the way, let's actually just kind of go and look at a few things that I kind of want to talk about as far as demo goes. And before I just switch things over, apparently I have to leave presentation mode. Okay. So kind of already saw this. So when I use the Arduino IDE, I really like to turn on all the verbose logging, so we get all this kind of output right there. So you probably, so you've heard, if not from me tonight, from other people, that the underlying stuff for Arduino actually does use C and C++ and all this other stuff. And so here's the output of compiling the application that I had just here. There's a couple of lines you'll probably notice there. I'm not too sure how well you can see all of that stuff, but it's specifying the board itself. If I actually go down here, it's using AVR-G++ to compile, and it's specifying the actual file, so or which file. So there's a C++ file, all that stuff, and you can kind of reverse engineer, how to create, something with the Arduino. So if you ever actually just want to create a C++ application and use the Arduino stuff, you can go ahead and do that. That's possible. I tried that at one point, and I had a bunch of issues, so good luck to you if that's really what you want to do, go for it. I've been told it's possible, again, according to the internet, so I have to trust it. This tab right here has all the information for deploying to the Arduino itself. So all the stuff that I wanted to do, I'm still using the Arduino board because it's really good, it has everything on there, and I already had it wired up. So that's all still good. So again, you can use the output here to kind of reverse engineer how you would go about doing this. There's still some AVR-G++ for doing whatever that is exactly. I'm still not 100% sure, but you scroll down a little bit, and you see the output of this other application, AVR-Dude. And so if you haven't heard of that, AVR-Dude is it's a good application for deploying to AVR boards themselves, maybe just Arduino. So I'm not actually 100% sure, but that's another thing that you use for deploying to an Arduino. So now that we have that out of the way, just talking about that stuff, let's go ahead and in Visual Studio right here, let's just pull up a solution. So what we're looking at right now is a CMAKE file. And so the CMAKE file is used to define everything from the build to the deployment to the unit tests, essentially, of how all of that works. So because earlier I was talking about CMAKE being cross-platform, cross-IDE, you can load the CMAKE file or CMAKE lists.txt file in any IDE. I prefer to use Visual Studio. Visual Studio Code also has some stuff for that. I installed some extensions or something else that I can't even think of right now. So whatever your preference is, there's a decent chance it'll work with that. If I just kind of, all right, you know what? Let's go back to the presentation. And we'll wait for it to actually pop up again. All right, so let's talk about some basics on CMAKE. We already talked about CMAKE lists.txt file, and that's pretty much where all of your CMAKE related stuff is going to go. It is a Turing complete language, essentially. I had to look that up. I used to work with a guy who said, as long as we have a Turing complete language, we could do anything. I'm just really glad he never said that we should develop with PowerPoint, because that's possible apparently. Although it makes for some pretty cool videos if you go online. So with CMAKE you can make variables, you can call commands, that kind of stuff. So with the CMAKE file, like I said, it has everything. You say what you're going to be compiling, you set your language that you're going to be using, etc., etc. There are a few gotchas with this. You do have to manually specify which files you want to compile. There is technically a way to do a search of the directory, but that only happens once, and so if you add a file, and then it's not going to do that search again. So that is something to remember, and that's something I mess up on a very regular basis. These lifetime scope of variables in CMAKE lists are a little weird. I don't fully understand it. You set an object, or you set one as an option. I'm not 100% sure when to use one over the other, and also with the CMAKE file you can call another one, and you can set those variables to work across scripts or not. Things will get weird. And then finally, if you're using Visual Studio like me, there is a CMAKE settings.json file. Basically that file right there, the thing that's nice about it is that's essentially the file where you set up how you're going to be running CMAKE basically through the command line, because it's a whole command line tool set. So in there you're setting all the parameters that you want to use. So any other IDE I assume has probably something similar, or you just kind of roll your own thing, your own script. So let's go back and actually talk about this file, what it does, how it works. So let me go to the CMAKE settings JSON file. So this is the one that I mentioned Visual Studio specifically is using to just kind of specify the settings. So I actually have two separate configurations. This first one up here on top, it's named x86 debug, and that's because that's what I'm building it as, an x86 application. So x86, not something that's going to be running on the Arduino itself, you know, because that's not 8-bit APR instructions. The reason that I have this one separate from this one below, the one named ARM 8 release Arduino Pro Atmega 328-3.3v, is because this is actually what's going to be built and deployed and sent down to the Arduino itself. The differences between these two are really just that x86 one is for those unit tests that I want to run. And then down here, this bottom one has a bunch of extra command line parameters to know how to actually send and deploy down to the Arduino and do all that stuff. So now, this script, the CMAKE settings JSON script itself within Visual Studio is used to grab the parameters to actually call CMAKE, which again uses this file, all that stuff. So remember when I mentioned differences in terms of setting variables? Here we have a set for a variable. Here we have an option for a variable. Again, I'm still not 100% sure when to use one over the other, but the internet made it seem like what I'm doing is pretty accurate, and so far this works. So within the script, I'm also setting a few other variables, other parameters. So if we're building for the Arduino, I'm setting these other variables or adding these other definitions. Otherwise, if we're building the test information, then I'm going to set some other variables, stuff like that. We'll scroll down, and then I have a set or a couple of sets. So I'm setting this variable as a list. So these are essentially all of the files that I want to be compiling and using. That's where I'm setting them here, and I'm kind of separating them just kind of based on folder, essentially. So if we kind of look at the files over here in solution, it's one app logic source files. So that is app and app logic, and so that is the source files here: app runner, app settings, those kinds of things. So it's those files. Then when I scroll down a little bit more, we have our include, and then as far as just building the application, we just need to pipe all of those things into the add executable. So that'll actually go ahead and build it and do all this stuff. In my application, I also have a subdirectory of the third-party code that I downloaded. And so notice the little comments right there that you know, I would rather have them all together, but you know, that's a C project and everything else I've done is in C++. So you know, let's just let it do its own thing with its own CMAKE file and all that kind of stuff. So we're including that. And so I don't want to get into this too much just because, then we're all looking at code all day, et cetera, et cetera. But I do want to scroll down to this else if instead we're doing the unit test executable. Then we're pretty much going to do similar things, but we are instead going to make sure we include Google Tests, so that way we have the unit testing type of stuff. And then we will build our executable specifically with source files and test files. So the file names are a little bit different than what we had earlier. There's less files, but now it's just the ones that we actually want to have our tests for. So with that, let's look at some of the source code essentially that we're building. So I'll go ahead and start with main. I think that's a good spot to start on. And then down here in main, we are initializing a few pins. We're setting up, we're saying that this pin is going to be an output pin. That's the LED that'll blink every time it receives a message from the transceiver. Setting up some settings. We're initializing the transceiver itself, and then while true, we're just going to run the device. It's just a loop, right? Forever, we're just going to be checking things. And so let's actually go. Oops. So if we go into that, just that way you can kind of see how this is running. For every device frame, it's just going to check if it's been time long enough to transmit a message, because we only want to transmit a message once I think it's every second is what it's based off of. And then if it is, we're going to broadcast the message, not broadcast. So that's
broadcast is the copyrighted term. So.
Yeah. Okay. Good to know. All right. And then we also want to check if we want to receive a message, and then we will handle receiving that and all that kind of stuff. So we're sending and receiving messages. I mentioned earlier that all of these messages are custom messages, right there, because it's not Wi-Fi or Bluetooth. So it's not. I mean, still kind of a lot of those. A lot of the same principles as far as sending packets and all that kind of stuff. The packet size is 62 bytes, I want to say. There's a number somewhere in the code. So because of that, we need to either separate the packets ourselves or just kind of design for something really small. So let's talk about the messages and how those actually work. And so that is under message handling. So let's go ahead and open. So there's only one type of message that this set of code knows how to work with, and that's the device broadcast message. So it's just continually sending this. So the way that this message works is it has a couple of properties. I believe this one only has two, so two variables. The device ID and the device type, so just two things that are set, two integers essentially. And so whenever we want to send a message, we need to serialize it. So we need to serialize it down to bytes. And so the way that works is we just have an array, and let me go to the header code of this, and it's not in here. That is over here. All right, so we just have an array, and we're just going to be setting, the numbers in the array. That's essentially it. If you want to go a little bit more in depth, like I said, all the code's on GitHub, so you can kind of see exactly how that's going. But in order to do that, we need to actually start setting, where in the array that's actually going to use. And so that's where this conversion utils comes from, and that is, I just want to show you, that is an instance of int byte conversion utilities. So I want to show you the logic behind that really quickly, because that'll lead into the one of the other things as far as talking about testing too. So whenever we're serializing a number, the code here is just serializing integers, essentially down to that byte. So it receives the number and then the array that we actually want to set it to, and then it just starts setting that stuff. So who here remembers bitwise logic with the and, or, yeah, all right. I had to completely reread up on all of that stuff because I never really knew it well. But now I think I know it pretty well after working with all this. So it's just because it's a 32-bit number, right? So there's 4 bytes. So if we're setting a byte array, then we're just going to set them, at index 0, 1, 2, and 3, and all that kind of stuff. And so when we're doing this, and I had a bunch of issues with setting a 16-bit one. So there's some extra code there, different code. But when I was doing this, I wanted to make sure that this was all accurate, right? Because like I said, I still have no idea how to actually debug this on an embedded device. I know debuggers exist. I have not worked with one. I need to buy a hardware module. I know for that, if anyone knows how to do that, would ever like to give one of those talks, I would love to be here for that. So that's where the unit test concept comes in, right? So let's kind of switch gears a little bit on there and talk about that. So you probably have noticed if you're looking around, I have every folder right here has a test. So message handling, it has a test folder. The utilities also has test. So in the CMAKE list file, one of the things that we do right here is add this, add the subdirectory, the third-party / Google test. And so within there, it has its own CMAKE list file. So now we have CMAKE list calling another CMAKE list. There is some guidance online around how many times to have CMAKE lists. Some people say every subdirectory should have one. Some people say it's a lot easier to just have one at the top. I started with the one at every subdirectory, and it just caused too many problems. And then I went to one at the top, except in the 2 other small cases. So this CMAKE list, which I pretty much just copy pasted from the internet, what it's doing is actually just going onto GitHub, and it's downloading and compiling the Google test stuff. So one of the things that I really wanted with this that I can't do with something like Arduino or something else is I want to be able to just download the code and hit compile and let everything go ahead and run. With having installed some other things. I don't want to have a bunch of things just kind of set up and do the right dance and all that kind of stuff and make sure that it works. So now the downside is that every time you want to build, or the first time that you want to build and start up, you do have to have an internet connection. So that is kind of a downside to that. But most of the time we're good, except that one time you really need it to work. So the way that this works, like I said, it grabs that and then it actually uses this other file, cmakelist.txt.in, and it uses this to do the full download, that kind of stuff. So let's actually look at the tests themselves so you can get a general idea of what they're doing. So let's go back to that utilities one, since we kind of talked about that a little bit. And so the test right here, so if you've ever worked with any kind of unit testing framework, this is probably pretty similar to what you've already seen. So you have a test, and then you have a test name, and then I guess.
Suppose we haven't.
Okay, all right. So with this and pretty much other ones, the idea behind a unit test is you want to, or unit test specifically, you want to test just the logic. And so this isn't running any integration tests. It's not running on the board or any of that kind of stuff. So I just want to create an instance of my conversion utility and give it some value, and then the value that comes out, I just want to verify that it's good. So Google Test is an XUnit style of unit test framework. So that just means that it has a few things like at the end, once you're done, you call expect something or assert something depending on which framework you use. In this case, I'm expecting that the value that I'm expecting, 0, is this value. So you're just saying, is this thing this other thing? It's just you're verifying that this thing is equal to something else. So I use the expect equal on a regular basis. Other times there's expect true, false, which doesn't seem to be in any of these, but same concept basically. So create an instance of the utilities, and then we call that method. We serialize the 32-bit integer number, and then I have some other code in here, just a little utility thing, a slice. So that's just going to grab the value at a specific index. So one of the things, yes, sir.
So let me make sure I understand what you're doing in the big picture.
Yeah.
You got the code which was originally targeted for the AVR
Yes.
in some library, and you're basically writing an x86 or Windows test program for that code. So you're recompiling it on Windows,
Exactly.
testing it on
Yep.
Windows.
Yes. Yeah.
Okay.
Yeah.
Because
So this
it's
is
difficult
only
to test it on the targets platform.
right. Exactly. Yeah.
Okay.
So yeah, because if you're running on the target
Took me a while
platform,
to get that. Okay.
yeah. So if you're running it on the target platform, in this case on the Arduino device itself, then that device is it's going to be a little bit slower, all that kind of stuff. But if you want some rich information at least about any errors that you have, it's a lot easier to just run it on your machine. So these are just testing the logic of the application, making sure that when you set a value in an array, that value is actually set. So yes.
Are you okay with me asking questions?
Yeah, go for it. Yeah,
Okay.
good time. I think.
So the ATMEL, is that a plugin for Visual Studio? And
No.
it's its own application that looks like Visual Studio?
So it is its own completely separate application, and I had planned on actually talking about it, but I got too excited and skipped ahead. So going back a little bit, yeah. So ATMEL Studio is a separate application made by ATMEL, but they were bought by
Sold
someone
ATMEL,
else.
but
Yeah.
They're bought by Microchip.
There we go. Yeah, Microchip. So yeah. So
The PIC people.
Yeah, those people.
They make the PIC. Microchip makes the PIC.
oh,
The
okay.
PIC processors.
Oh,
Yeah.
all right. Yeah, so this is ATMEL Studio. Sorry, and I meant to talk about it. Basically, like if I were to open up the new project dialog, you get a nice little pop-up, here, just like in Visual Studio. Yes.
Wow. That last
Yes.
option.
Yeah, exactly. Yeah, create a project from an Arduino sketch. Yeah, so you can do that. But that does actually create an Arduino project itself. So it's not converting it over to something like C or C++.
Oh, it doesn't?
No, yeah, no. That's what I thought too. I was like, oh, this will be really cool. Oh, that's not what I wanted.
Actually, all the big chip manufacturers, including ATMEL, generally they produce some kind of GUI. Like the TI has one, and
Code Composer.
yeah. So yeah, that makes sense that they have this. Sometimes it has debugger. Well, in order for the debugger to work, you have to have some hardware hooks, I think.
Yeah, so there is stuff in here for a debugger as far as tools to be able to set that up. The hard part, or the downside, is you have to go and set that up yourself. And so that's something I was kind of skipping over when I was playing with this, because I don't have the hardware for it, and then I couldn't really find a lot of information online. And that's one of the reasons kind of wanted to talk about this, because getting started with this was way harder than I expected. There's a ton of information on the Arduino, lots of that. The other stuff we're talking about, no, I had to piece that together. There's a lot of forums online from 10, 15 years ago. You can find a lot of that. Not always the information you need, though. But, yeah.
AVR freaks or whatever.
Yes, yeah, I ended up on AVR Freaks a lot. Yeah.
That brings back memories.
Yeah. So something to note, that AVR, you probably keep seeing the phrase AVR on the screens. We keep mentioning that. AVR is the chip platform. Maybe I'm not saying that right, but it's basically the chip that runs on the Arduino. So it's the little 8-bit microchip, the CPU itself. So it's that kind of stuff. So very different.
I think it's actually 16-bit.
Uh,
Anybody want to correct me on that?
Well, yeah, that's a famous argument right there before. So.
It depends. I know the one, specifically the Arduino that I have, is 8-bit, the one that I'm using. Some are 16-bit.
Mega 328.
I was told it's 8-bit on everything that I've seen.
328, I think is 8. I think you're.
Okay.
I think you're at the mega.
But
maybe
bit,
it's that.
that's a line match anyway with bit width. So so you take the data bus, you take the instruction bus, you take the size of registers. It's a line match.
Gotcha. Yeah, that's kind of what I've seen from the very few things I've looked at. Yeah. So talking about ATMEL Studio, since we're here, I didn't want to go too far into the code because I kind of wanted to specify more things specifically on the Visual Studio side, or really on the CMAKE side of things. But basically, ATMEL Studio just uses the shell of Visual Studio, so it's a completely separate install, and it has quite a few things. And actually, let me make a new project, because I do want to show one of the things that it does that is actually really cool. When you create a new project, it gives you a list of all the chips or devices, platforms that it knows about, and you can just kind of go through and select them. And so if you know you're using a specific board, then it'll set a few properties that it knows to say things like, oh, okay, so you have 256 kilobytes of memory. So that way when you're compiling the application, if you have way too much that can go on the board, it'll at least kind of help you out and let you know about all that. Yeah.
Can you do the drop down for the device family?
Yeah.
Oh, nice.
Mm-hmm. So the ATmega 328P, I think is what I was using. Yeah, there you go. So that's the one. So 32 kilobytes of at memory itself. All that kind of fun stuff. Yeah. So it can help you with all of that, but as far as getting a lot of stuff set up, there was a lot more manual stuff than I had expected for that. Yeah.
Can you please scroll down to support tools on the right?
Yeah. So supported tools. All right.
Okay.
Yeah. So that's the full list. I don't fully know any of those.
There's a simulator. A lot of them have a simulator you can use if you like to work at that level. But of course, simulation's not the same thing as.
Yeah. I mean, and something that you could help. I've never worked with the simulator. I tried. Again, it was tough getting that set up with the zero knowledge that I started with. So that was just a little tough. I know these top two, ATMEL ICE and AVR Dragon, are for debuggers. Are all of these debuggers?
Yeah.
They interface to the chip, usually to the JTAG port on the chip, which is often pinned down. And they actually let the debugger stop the chip on instruction boundaries. So you can all the things you do in a normal debugger, you can single step, but you do it remotely. So you tell this device, and it says, okay, go one instruction, and it stops and it shows you it reads all the registers and stuff. So it puts in usually a dedicated debugging port on the board.
Yeah, on the Arduino, that's that 6-pin port that's on there.
Oh, cool. Okay.
And it has like a serial USB connection back to your box.
Gotcha. Yeah, so I did see a little bit of information online about getting started with that, but then you have to buy one, and finding one was the hard part. Finding one to buy that was at a decenter price range.
That's why everybody likes Arduinos, because you don't need any hardware.
Yeah, exactly. Yeah. So this could be a very good place to go, and there's actually a bunch of other tools too that are really useful as far as the ATMEL Studio goes. But again, the whole setup process and knowing zero. So I think I'm pretty much out of time. I do just want to kind of, let's see.
We did ask a lot of questions.
Yeah, so let me just finish this as far as the unit tests go. So let me actually compile this. So when you're using a CMAKE project in Visual Studio, you get a CMAKE toolbar right there. I'll just go ahead and hit rebuild. Because I have the x86 one selected, so remember when I had that JSON file open, I mentioned there are two targets, so there's the x86 and the ARM8 one. So right now I have the x86 one selected. So the output is going, it's still running, it's still doing the rebuild. I believe it should have already downloaded all the Google test stuff yesterday when I loaded all this up on my machine. So the build succeeded. And then
Only 5 warnings.
You're
done.
good.
And we can safely ignore all those warnings.
So, and then you can go ahead and run your CMAKE test right here, or you can just go ahead and, if you like the window, you can go ahead and open the test here and go ahead and run them all through the graphical editor right there in Visual Studio. And so that'll just run them all on your local machine. So that's running them, all that stuff. Hey, and all of those pass. Woohoo! And then if you want to switch over here to the ARM8 one, some of the options actually do change. You do get this little warning pop up about the IntelliSense, but that's a whole other thing. So I'll go ahead and rebuild again anyway. This will be a little bit quicker just because some of the things it does. But so it's running, there you go, build succeeded, woohoo. We get a little bit of output of things because we know what the board is. So it says, hey, how much memory you have, all that kind of stuff, right, for the app itself, its size. And then within the build script I have, something I didn't talk about is we have some targets of things that we do. So if you want to deploy to the board itself, you kind of have to create something to do that. So a build thing that the CMAKE build script is doing, I created one called upload to device. So I can go ahead and click that one. And go ahead and click on the output, and that failed because that is on, I think that might be on the wrong COM port actually. So let me go ahead and very quickly make that change in the JSON file, and that's just a setting that I have. So let me change that to COM port 3, which is dependent on the where Windows picked up that it went. So let's try that one more time. Let's deploy that out there. Now this one actually kind of takes a bit. So I can see right here, but you can't because it's hidden by all this stuff. All the lights are flashing and all that. Hey, and there we go. So avrdo.exe ran. It's successfully on the board, so it has deployed. Yeah.
So you called it from CMAKE?
Yeah. So let me quickly show you where that is in CMAKE. So the actual code, I guess, for uploading is within the entire section I have of the if it's actually building the app itself, if is building embedded app. So first we create the executable, and then we do a few things. We add target libraries, so got to link it to the other libraries that I built, in this case the third-party one for the working with the transceiver. And then I added this function to, which is this one? No, that's just for creating extra files. So still not 100% sure on the 3 different types of files, an ELF, hex, and an EEP. But from everything I saw online and from what I copy pasted from some CMAKE script, all 3 of those I think are needed. Someday I'll actually go do the reading about what exactly they are. But these are just for creating those files based off of the original target of what you compiled. And then let's see. And so eventually we get down here. So anything in blue right here is calling a built-in command. So this last one, add custom target. This is what's actually used for deploying from my machine onto the Arduino board itself. So this will actually deploy it. So it's calling AVR do. So it's using that application I mentioned before. I called out when we were looking at the Arduino IDE. And that AVR do variable is set up here. And I did kind of want to call this one out specifically. So that one's set right here. Notice I have a to-do comment right here. Figure out how to use this without needing the Arduino installed. So there's that. So I've got to find out where that is. Also, if you remember when I had the PowerPoint slides up, one of the things I mentioned that's kind of a con about CMAKE is that if you're working on different platforms, it's very easy to to fall into using one to get it to work. So I've kind of hard coded the a Windows path essentially, right? So someone on Linux who should have the tools to build this won't be able to do that. So something to keep in mind for that kind of stuff. But yeah, once you have this custom target, so the name upload app to device, I just click on CMAKE build only, and so it'll run one of those targets. And so now you can just kind of build your own script of things that you want to go ahead and do and actually use there. So let's see, let me jump back into the slides. I think I have 2 or 3 left. Let's see if there's anything else. We already talked about the unit tests themselves. So again, they're running on the local machine, not on the embedded hardware. We're using Google Test for that. All of that is just on GitHub, so whenever it does the build, all that, it just downloads it out. Other things that if you want to look into, or things that I plan to look into at some point, are the debuggers. We had a whole little mini discussion about that. Other build systems too for C or C++, there's a nice link right here of a list of a bunch of them. CMAKE is, when I was kind of doing some research, CMAKE was the one I liked from all of those. It's basically just a script for what you want to do, but if something else is a little bit better, go for it. And I've been hearing some cool things about Rust for doing embedded stuff. There's a community project for that right now, and actually today, there were a few presentations at Embedded Conf in, I think it's in Berlin. So I'm really hoping some of those videos make it online on YouTube or something. I can watch those later because I hear really good things about Rust. As far as other systems, after I started creating this presentation, I learned about these 2 things. Arduino has a CLI now. I don't know how mature it is. It was only announced a month or 2 ago. And so it's basically for scripting scenarios. So that might actually be a little bit better of the kind of the CMAKE route type of thing, right, where you just call the CLI with a script that you want to use. And IoTZ, that is kind of a wrapper around some of these other things, and I haven't really played with it. I saw one really quick video. It actually looked really cool. It just has a bunch of it just kind of has the other tools that it knows about, so one of those things. And it's an NPM package, so it's really easy to install. And then other resources. So this book, ATMEL AVR Microcontrollers book, was really helpful in just understanding basic concepts of developing on an actual AVR board itself. It's not specific to an Arduino like I was using. It just kind of goes over some of the things like registers and how all those work. It actually talks about it does show you code. Pretty much every example is in C, C++, and IL if you want to use, or assembler if you want to go that route. I just skipped over the 2 of those languages I didn't really care for. But that is actually a really good book, so if you want to learn about this stuff, that's a good one to go for. And that's the end of the slideshow. So, any questions?
I have some commentary on the debugger thing, but I guess I'll wait till they get on that.
Oh, I don't know how to work with it.
No, that's fine.
Oh,
so
okay.
I found another solution to this,
yeah.
which is called vMicro. It's a plugin, actually a plugin to Visual Studio, all self-contained. They have their own software debugger, and it's like magic. But basically what they do is you can add breakpoints in, And behind the scenes, when you build it, it basically adds serial breakpoints in that you don't see. And so it stops the code. You can inspect variables that you set, all without any sort of fancy hardware.
So insert breakpoints into the target code, right?
What's that? Yeah.
Insert breakpoints into the target.
Yeah. So it's running on the device.
Yeah.
It pauses, sends the sends it back to you.
V Micro spelled that way?
Yeah.
All right.
It's paid, so it's not, it's like $30 for a personal license, but it's
Cheaper
really
than-
cool.
all
It
right.
puts it right in Visual Studio. You get your project. You can see it a few different ways. Debugging's worth $30 to me.
Cool.
So.
Yeah, exactly. That's cheaper than all the other things I've
Yeah.
seen online too. So that sounds great.
And it's not full. You can't like piecewise step through all the code. You have to put the breakpoints in and then rebuild it basically. But it's really cool.
Still better than the nothing. Yeah.
Yeah.
Doesn't SparkFun have a debugger?
They do or did. I could not find one online, and I couldn't find or. I spent like an afternoon, a whole like evening or something looking into this, trying to find one online, and I found one for people were saying you could find it online for $100. I thought, well, maybe I can do that, but the cheapest one I found was about $200. So
SparkFun had something that would let you flash boards. I think it was severely crippled from what a real debugger could do.
Okay.
Dragon's pretty cheap, I think.
I think that's the one that I had heard of.
Yeah.
Yeah, and it was, but I
Yeah,
had trouble finding it. Yeah, it's and I didn't try super hard. That might have just been me being lazy too. But
There's also the risk versus reward of going out and buying a bunch of different things and not knowing if any of them are going to be what you want.
that was one of the things that kept stopping me. Yeah. So I mean, eBay probably would have been great for that, but how much do I want to trust that? Yeah. Any other questions? Do
Have you looked at Platform IO?
I did look at it. A lot of the stuff I saw seemed to be kind of the very little bit that I looked. My first impression was that it reminded me of the Arduino stuff in that it's, as far as being able to do things that I wanted to do, the unit tests were always a big thing to me. I wasn't sure how to do that in there. I didn't really see some documentation on there. And then some of the other things for like making a project and kind of keeping it. And I really should have looked into it more than I did. I kind of installed stuff and.
I don't know, about 6 months ago they switched. It was based on Atom before, but they switched to Visual Studio.
Yeah, Visual Studio Code.
Visual Studio Code.
Yeah, I installed the extension, and so I kind of looked at it, but I really should give it some more. It seemed like it was more targeted towards a specific, like when you create a project, you choose your platform sort of thing, and what I'm saying now doesn't really sound like what I'm actually thinking of it in my head. So I'm not describing what I thought very well, and that also was probably very wrong too. But I should look into that. Or have you looked into it, and would you like to talk about it here?
I have. I'm doing a project with it. So.
Oh, okay. Cool. All right, because I would like to learn about it. So cool. All right. Anything else? Questions? Comments? Do you want to teach me anything too?
Yeah, actually, I was going to say something about AVR Dude.
Mhm.
Yeah, so what separates an Arduino from just a blank ATMEL 328 chip is that it has a bootloader running in there, which means every time it starts up, it'll run that code, and it will check the serial port to see if the computer's trying to send code down.
Oh, okay.
So AVR Dude is designed to work with that interface. It may have other features as well, but it's designed for that. So if you tried to just program just a ATMEL 328 chip that you bought, then it wouldn't work. You would need to load that bootloader code on there first.
Which you can do with taking yet another Arduino. I tried it.
I did see that online about using an Arduino as a bootloader, and all right, I didn't
One
want
more
to
thing,
deal
this
with
is
that.
mostly an academic point. The reason you don't see mu in there is not a standard library issue. Mu is not in the standard library. Use a keyword in the C language, C++ language. You don't see it because embedded programs hardly ever allocate memory dynamically. It's a bad thing. Because in an appliance application, all you're doing is adding indeterminacy to something that's going to run forever anyway. Dynamic memory is mostly useful when things grow and shrink and they change. If you have a product embedded in a microwave oven or something, you want to allocate everything statically to get everything as deterministic as possible. Because in the process of viewing and deleting, suppose memory becomes fragmented, then you're screwed.
Yeah, and that's something that I was looking online a lot at some stuff, and some people said, it really depends on the board that you're using. If you know exactly what you're doing, you're good, but the potential, has a chance of things ending badly. New was the example I wanted to use. There were lots of other things too, as far as the standard library goes, that you don't have as much access to.
Yeah, you're mostly missing I/O. You have all the string functions, and
Oh, really? I missed
Oh, yeah,
it.
yeah.
Oh,
If
okay.
you love store copy and the rest of them, you have them all. There's SPRNF, all good stuff. SPRNF, of course, drags in
Yeah.
a 4K code, but
If only we could figure out a way to just take that memory and clean it up somehow, you know, maybe collect it, like it was garbage of some kind.
Mhm.
That would be neat.
we should.
I'd like to work in languages that do that.
That'd be great.
And there's
Um,
like
If you trust them to do it.
75% of the RAM on an Arduino.
Well, you can get an amazing amount of code in an Arduino.
You can, yes.
You'd get, depending on, you run out of RAM first, because RAM is tight, like 2K, most boards. But running out of Flash is tough. I had 1,000 lines of C++, and it fit. So it ran out of RAM. The Flash were fine. It's amazingly efficient compiler and architecture for the size of the code produced.
So, if anyone here doing ESP32? Anyone familiar with that?
Well, that's it.
I've used that.
I started playing around with Arduinos and quickly ran into, for what I'm doing, which is some cloud connection stuff, ran into just not enough there. The ESP32's got like 4 megs of flash
That's
and
crazy. That's great.
300K of RAM or thereabouts. And
It's desktop machines nowadays.
it's $3.50.
Oh, yeah. Price is not an issue these days.
Yeah, since we were talking about the library that you have access to, and one of the things is that when you install ATMEL Studio, and actually the same is true for the Arduino, it has the library too. But this is kind of the AVR standard library. I don't know if that's a right phrase to use for that, but you can just include this stuff in your library, and all of that will be included for you. And actually, one thing I kind of wanted to mention really that I didn't really when I was talking about the CMAKE versus Arduino. The Arduino tools are a little older as far as which version of the compiler you kind of want to use. ATMEL Studio does go up to C++ 17 for which version it'll use. Arduino, I think the compiler stops at C++ 11, so depending on which features you want to use. So you don't have to install the entire ATMEL Studio onto your machine if you don't want to. You can just install Arduino and use those tools, and you're good with that. But that's it. So cool.
Well, I guess something else I would want to mention is
Okay.
you can create a Arduino hex file from ATMEL Studio. I know that's not what you were going for with this project, but yeah, if you wanted to just write a whole microcontroller project in C and have register level access and interrupts and timers and all the rest of it, you could write it in ATMEL Studio, and then using certain compile options, you could compile it so then you could use AVRDO to then load that onto your Arduino.
And so in the end, the hex file, I mean, that's just the compiled
Yeah.
application, right? Okay, yeah. So
And I think it literally is in hex. It's been
Yeah.
ASCII-fied. basically.
Yes, so yeah, the hex file, because you were asking about the
Yeah.
ELF versus the hex versus the EEP.
Yeah,
The
that's
ELF and
different, yeah.
EEP are some kind of intermediate files, but the hex is as compiled as it will get before it goes onto the chip.
Gotcha.
Like the hex file contains like what memory address is supposed to go into, how many bytes it's about to send over, and so it's formatted that way, but that's totally compiled otherwise.
Gotcha. Okay. Cool.
Ask if I.
All right.